Good afternoon, sir. Good afternoon, students.
Good afternoon.
Yes.
Well,
So, shall we start?
yes, ma'am. Yes, ma'am.
Okay, fine. So, today we are going to see the questions based on the topic amines. Okay, so what are these amines? What are these amines? So, amines are the compounds, okay? Amines are the organic compounds which contains nitrogen atom, right? It contains nitrogen atom. So, how they are represented? NH2. Okay, RNH2 is the functional group. Okay, R can be your alkyl or the aryl group. So, NH2 is your amines. Okay. So whenever you're naming any amines, so they are based, first you're going to name the alkane and then you're going to name the amine. Okay, alkane amines. Okay, E will be replaced by your amine. So like that. So amines, so when we are discussing amines, so they are the organic compound which contains nitrogen atom. Okay. So basically in amine chapter, so what all things are there? So here you are going to study, already you might have gone through the physical properties, chemical properties, preparations of amines. Okay, different important name reactions. Okay, very important name reactions. Then about the basic nature of amines. Okay, then also about the diazonium salts. Okay, there is something important concept in amines, that is diazonium salts. Okay, so based that also in diazonium salts, how to prepare the preparation of diazonium salt. Okay, and physical properties, chemical properties. Okay, so these all things are included in this particular chapter, amines. So from this chapter, okay, let us start with the questions. Okay, so this is the first question. Amines behaves as, okay, amines behaves as a protic acid, a protic acid, okay, a protic acid, B neutral compound, C Lewis acid, and D Lewis base. So how does these amines they behave as? Okay, so amines, as we know, they are represented by RNH2. Okay, RNH2 is the functional group for amine. So they nitrogen. Okay, when you see the nitrogen, so nitrogen, it is what? 1s2, 2s2, and 2p3. Right. So when you see the hybridization of nitrogen, okay, when you see the structure of nitrogen, it is what? It is tetrahedral structure. Okay. So it has three bond pairs, okay, and one lone pair of electron. Okay. So because of that, it is basic in nature. Okay, it is basic in nature. It is a base. Okay, because it can donate its pair of electrons. So so amines, they behave as what? They behave as a Lewis base. Why do, as we know, base, okay, base are what? They are the, so they will donate the pair of, so when, so they're in first year, okay, there are different in the ionic equilibrium, okay, in the chapter equilibrium. So you have a separate this ionic equilibrium. In that ionic equilibrium, you have already studied the different theories, okay, acid-base theory. In that acid-base theory about Arrhenius concept, Lewis concept, Bronsted-Lowry concept, right? Remember? So there is something Lewis acid, Lewis base. Okay. So these amines, okay, because nitrogen, it has a lone pair of electron on nitrogen. So it can what? It can donate this lone pair of electrons. So they act as what? They act as a Lewis base. Okay. So because as we know, amines are represented by RNH2 and nitrogen has lone pairs of electron. Okay. So they are able, amines, they are able to donate the lone pair of electrons. So they are called as what? They are called as the Lewis base. Okay. They are called as the Lewis base. Okay. Fine. Next question. Which of the following forms propane nitrile as the major product? Which of the following forms the propane nitrile as the major product? Okay. So there are different preparations. Okay. So in that, your this, okay, which of the following propane nitrile? So first, let us write the structure of the propane nitrile. Okay, so this is propane nitrile. Propane means 3 carbon. Okay, so and nitrile. So this is your CN group. Okay, so this is your propane nitrile. Okay, so here, uh, so how, so by which reaction you can get this product they have asked. Okay, so there is a, so from your, if you have this, okay, so there is one preparation from where you can get this propyl nitride. Okay, so there you are going to take ethyl bromide. Okay, ethyl bromide, what is the structure of ethyl bromide? CH3, CH2, Br. Okay, so when you have a alkyl bromide, when it reacts with your alcoholic KCN, okay, when it reacts with your alcoholic potassium cyanide, okay, your Br will be replaced by cyano. Okay, so your Br will be replaced by what? Cyano group. So this is, you are going to get a propyl nitrile. Okay, you're going to get a propane nitrile. So ethyl bromide, when you react it with potassium cyanide, okay, ethyl bromide, when you react it with potassium cyanide, what you're going to get? You're going to get this. Okay, so this here CN it should be. Okay, this is KCN. KCN. Okay, so option number A, ethyl bromide plus alcoholic KCN. So ethyl bromide, when it reacts with your alcoholic KCN, what you are going to get? You are going to get a propane nitrile. Okay, one carbon extra, one carbon extra. So what you can see, this is a one step higher reaction. Okay, you are going to get a higher nitrile here, right? Here you can see there are, it is ethyl bromide. So when it reacts with your alcoholic KCN, you are going to get a propane nitrile. So answer is option number A. Okay, when ethyl bromide reacts with your alcoholic KCN, you are going to get propane nitrile. So this is a method of preparation, one of the method of preparation of propane nitriles. Okay, how you can prepare nitriles from alkyl halides. Okay, next question. The correct sequence of reactions to convert para-nitrophenol into quinol is. Okay, so how you are going to convert your para-nitrophenol into this. Okay, so let us write into quinol. So what is the, so para-nitrophenol. So let me write the structure of para-nitrophenol. So para, so phenol, with respect to your phenol, okay, nitro will be at para position. So this is your para nitrophenol. So from para nitrophenol, I am going to prepare what? I am going to prepare quinol. So what is quinol? Quinol is OH at 1,4 position. Okay, so this is your quinol. Okay, this is your quinol. So what are the steps? Okay, what are the steps which are involved? So this is your para-nitrophenol. So now if I convert this nitro group into, so first step what I can do, okay, this is intact. Okay, this will remain the same because I want to change what? Only I am going to change this because I want OH here, right? I'll do reactions only at nitro group. Why? Because nitro group, I want to convert it to OH. This will remain as it is. So what I'm going to do first, if I convert, if I do reduction, okay, if I do reduction nitro to NH2, how it can be reduced? By doing reduction. Okay, reduction is what? Addition of hydrogen, removal of oxygen. So what will I get? What I will get? Removal of oxygen, addition of hydrogen. I'm going to get a NH2. Okay, I'm going to get a NH2. So what I'm going to get? Okay, I'm going to get a so this compound, right? So I'm going to get this compound. So what I have done, reduction. So reduction can be done using which reagent? I can use tin HCl. Okay, I can use tin and HCl. So if I use tin and HCl, I'm going to get this particular product. Okay, next step. Okay, now you know what is diazotization. Okay, how do you do diazotization? Whenever you have amino group, okay, on amino group you can do diazotization. using sodium nitrate, okay, using sodium nitrate and concentrated HCl and concentrated HCl. So when sodium nitrate and concentrated HCl reacts, okay, I'm going to get nitrous acid. Okay, I'm going to get what? Nitrous acid. So this is so this is nitrous acid. Okay. Nitrous acid. Okay, so how I'm going to get? So diazotization is a process where your NH2 group, okay, wherever you have a amino group, on that you are going to do diazotization. Why? Which is a diazotizing agent, NaNO2, that is sodium nitrate, reacts with your concentrated HCl. Okay, you're going to get nitrous acid. Now this, to do diazotization, the this what your uh, reaction, okay, it should be carried out at 0 to 5 degrees Celsius. Okay, this is the this what must, the reaction should undergo at 0 to 5 degrees Celsius. So that time I'm going to add this at 0 to 5 degrees Celsius only. Okay. You're going to convert, you're going to do the diazotization by using NaNO2. Okay. When NaNO2 reacts with what? HCl. Okay. What is the nitrous acid? Okay. This nitrous acid. Okay. So what I'm going to get? What I'm going to get now here? So again, my OH will remain same. Here I'm going to get N2 plus and Cl minus. Okay, I'm going to get the diazotized salt. Okay, I'm going to get a diazotized salt. N2 plus Cl minus. Okay, this is N2 plus Cl minus. Okay, Cl minus. Now, further, what I'm going to do? I'm going to do hydrolysis. Okay, I'm going to do hydrolysis, H2O. Okay, water in the presence of acid hydrolysis. What will happen? Your N2Cl. Okay, your N2Cl. Your N2Cl. Okay, what will happen? Your H plus will go and attach your Cl. Okay, you are going to get HCl, and your OH, okay, your OH from the water will go and it will be a nucleophile. Okay, this will replace your N2, and N2 will liberate as gas, N2 gas. Okay, it will be gone as gas. So this is the reaction. So what are the steps? First reaction is what we have done? Reduction. First, we have done reduction. Second step, what we have done? We have done diazotization. So what is diazotization? Whenever you have a amines, okay, whenever you have amines, okay, we are going to react the sodium nitrate, okay, with concentrated HCl at 0 to 5 degrees Celsius, okay, okay, and your what will happen? Your amino group will be converted into a diazotization salt, that is N2 plus Cl minus, followed by hydrolysis. What will happen? Your Cl, okay, will get attached with this H, and you are going to get HCl, and your N2 will be liberated as gas, and your OH will be replaced. Okay, it will be the it will replace the this. Okay, so quinol. So like this. So what are the steps? First is reduction, second is diazotization, and third is hydrolysis. Okay, third is hydrolysis. So which is the answer? Which is the answer here? So what are the steps? Correct sequence of reaction to convert paranitrophenol to quinol: reduction, diazotization, and hydrolysis. So option number A. Yes, option number A is the answer. Okay. So next step, next question. Uh, the conversion of metanitrophenol to resorcinol involves respectively. So, to conversion of metanitrophenol. Now, metanitrophenol means what? With respect to your OH, okay, your nitro group is at meta position. Okay, your meta position. So, this is your metanitrophenol. So, this is metanitrophenol. Okay. So from metanitrophenol, I am going to convert it to resorcinol. What is resorcinol? When you have OH at 1,3 position. Okay, when you have OH at 1,3 position. Again, same steps, right? Same step. What I'll do first, I'll react it with tin HCl. Okay, I'll do reduction. What will happen? Your reduction is addition of hydrogen, removal of oxygen. So I'm going to get NH2. Okay, further react it with what I'm going to do, diazotization with the help of NaNO2 in the presence of HCl. Okay, NaNO2 in the presence of HCl at 0 to 5 degrees Celsius. What I'm going to get? I am going to get OH and N2 plus and Cl minus, followed by hydrolysis. Followed by hydrolysis. How I'm going to do hydrolysis? Okay, H2O. Okay, acid hydrolysis. What I'm going to get? Resorcinol. Okay, I'm going to get resorcinol. So what are the steps? Reduction, diazotization, and hydrolysis. Okay, so let us see which is the answer. Option number D. Right, option number D. Yes, option number D is the answer. Okay, let us go for the next one. Which one of the following gives amine on heating with amide? Which of the following will give you amine when heating with amide? Yes, so amines on heating with amide. So amides are what? R C double bond O NH2. Okay. So what will give you amine? Amine is this. So what you can see, there is one carbon less, right? There is one carbon less. There is no carbon here. One carbon is less. So this is a Hoffman bromamide degradation reaction. Do you know Hoffman bromamide degradation reaction? So this is a famous reaction, Hoffman bromamide
Degradation.
degradation reaction, right? So in Hoffman degradation reaction, we are converting the amides into amine, right? We are converting our amides into amide into amines. Okay, so you can see that in amine, one carbon will be less. The number of carbon from amide in amines will be less, one carbon less. So how we are going to convert the amides into amine? In the presence of bromine NH, NaOH, KOH, okay? In the presence of bromine and KOH, potassium hydroxide. So when you heat your amides, okay, when you heat your amides in the presence of bromine, okay, or and KOH, or you can use NaOH. Okay, you can use NaOH or KOH. You're going to use aqueous. Okay, you're going to use aqueous NaOH or KOH, not alcoholic. You're going to use aqueous NaOH or KOH. You're going to get amines with with lesser number of carbon atoms than in the reactant. Okay, so which is the this answer? It is option number A, bromine, aqueous, and KOH. Okay, so which of the following amine on heating with amide? Following gives amine on heating with amide. It is Br2 in the presence of aqueous KOH. So this is Hoffman bromamide degradation reaction. So whatever the number of carbon atoms are present in amide, you are going to get one carbon atom less in the reactant. Okay, in the product. Okay. So answer is option number E. And an aromatic compound A on heating with Na2 in the presence of HCl at 0 degrees Celsius forms benzyl alcohol and nitrogen gas. The number of isomers possible for the compound A is, so there is a aromatic compound C7H9 this, and you are doing diazotization, means it should be a amine. Okay, so if I take this as amine, so 1 2 3 4 5 6 6 carbon, again one carbon, so it will be, so see now, 1 2 3 4 5 6 7 8 9 10. So 1 2 3 4 5 6 7, right? 7, then 8, 10, 9. Is it? See now, C7H9, H9, this. So this is an aromatic compound. Okay, this is an aromatic compound. Now I am going to do what? I am going to treat it with NaNO2 in the presence of HCl. Okay, in the presence of HCl. Okay, what I am going to get at a 0 to 5 degrees Celsius. So what will happen? Diazotization will take place. Diazotization will take place, right? So So what will be the diazotization? It will be CH2 and N2 plus and Cl minus. Okay. So further, what will happen? Hydrolysis. Okay. Hydrolysis will take place. What I am going to get? What I am going to get now here? CH2OH. Right. CH2OH plus N2 plus N2 gas. Okay. Plus HCl. Okay. Okay. So N2 plus HCl. So what I have got? I have got a benzyl alcohol. I have got a benzyl. They've said no. On reacting aromatic compound A on reacting with NaNO2 HCl at 0 degrees Celsius form benzyl alcohol and nitrogen gas. So the number of isomers possible for the compound AR. Okay, so what are the number of isomers possible for the this is okay. So just see, so your benzyl amine, okay, it can how many isomers it can form. So one is your benzyl itself, benzyl amine. Isomer means what? The molecular formula will remain same, only the structural formula will differ. So another, it can be your CH3, NH2, 1, 2, 3, 4, 5, 6, 7, 3, 4, 5, 6, 7, 8, 9. Right. So yes. So this can be another isomer. Then how it can be? Then I can write meta para positions also, right? So that can be also isomer. So this is ortho. So I can write now meta, right? The same I can write it with para. So CH3 and NH2. Then one more NHCH3. So there are five. Total there are five isomer possible. Okay, so the number of isomers possible for the compound is 5. Okay. Yes, compound A is 5. So 1, 2, 3, 4, 5. So option number A. Option number A. Okay. Let us go for the next one. One of the following amides will not undergo Hoffman-bromamide reaction. One of the following what amide will not undergo Hoffman bromamide degradation reaction. So which will not undergo Hoffman? So for Hoffman degradation reaction, what is the conditions? Anybody knows? Who will undergo Hoffman bromamide degradation reaction? Only primary amides, right? Only primary amide. Remember that only primary amides will undergo Hoffman bromamide degradation reaction. Now find out which is the primary amide. Amide means it should be CONH2 like this. Okay, this is amide. Okay, now first one. CH3, C double bond O, NH, CH3. Okay, fine. This is the primary amide. Then CH3, CH2, CH, NH2. No, this is a amine. This is a CH3, C double bond O, NH2, which will not undergo. One of the following amides will not undergo. Okay, so this is a primary amine. Just a second. Huh? Now, so here, this is what? Uh, so this is a, what you say? So this carbon, this is there, another, so this is not. So here, okay, for this only one carbon is attached. So this is a primary amine. Okay, then your, which of the following will not undergo, they have asked. Right. So here then C6, C6H5, C double bond O, NH2.
Option A,
Option,
ma'am.
yes, yes, option A. Okay, it will not undergo Hoffman bromide degradation reaction. Okay, Hoffman CH2. This is CO. Okay, this is also CO, not CH. It is CO. Okay, so CH3, CONH, CH3, CH3, CH2, CONH3, 3 CONH3, CH3. Okay, so so this is also uh, primary. So here you can see, okay, both side this is there. So option number A, option number A. Fine. Let us go for the next one. So only remember that Hoffman bromide degradation, it will only primary, okay, only primary will undergo. Only primary amides will undergo. Okay. Okay. Gabriel thalamide synthesis is used in the preparation of primary amines. Okay. Gabriel thalamide synthesis, it is used where it is used in the preparation of primary amines from Thalamide. Okay, from thalamide. Which of the following reagent is not used during the process? A. NaOH, B. KCl, C.
Option B, ma'am.
Okay, just a second. Very trend. Hmm. So Gabriel thalamide synthesis is used in the preparation of primary amines from thalamide. Which of the following reagent is not used during the process? A. NaOH, B. HCl, C. KOH, and D. alkyl halides.
B, HCl, ma'am.
B.
HCl.
HCl. Okay. So, what is Gabriel thalamide synthesis? So very important, very, very important, Gabriel thalamide synthesis. Okay, so this is your thalamide. In the first step, what you are going to do, react it with KOH. What will happen? Your this, okay, restol will remain the same. Okay, you are going to get a potassium salt of thalamide, right? You are going to get a potassium salt of thalamide. Then what will happen? Potassium salt of thalamide. Further, I am going to react it with alkyl halide. This will be replaced by your X, right? And R. Okay, R. Then now further, what you are going to get? Okay, I am going to get a phthalic and one primary amide. So like this. So here the breakage will take place, and I am going to get CONA plus and C double bond O Na plus. So KOH, if I can use either if I use KOH here, again I'm going to use here KOH only. Okay, if I use NaOH, I'm going to get NaOH. So I will take K plus only. Okay, so like this. So this is, I'm going to get only primary amine. So from Gabriel thalamide synthesis, I'm going to prepare only primary amine. So NaOH used, KOH is used. Okay, NaOH used, KOH, alkyl halides I use, HCl is not used. So option number B is the answer. So this is the reagent which is not used. Okay, in Gabriel thalamide synthesis, which is not used is HCl. Okay, very important. Okay, please study Gabriel thalamide synthesis. Very, very important for your board exam. Okay, Hoffman bromide degradation also very important for board exam and for CET point of view. Okay, they can ask you how they have asked, no, based on the applicative type of question, it can be asked. Okay. Next, the correct order of increasing basic nature for the bases NH3, CH3, NH2 in aqueous solution. CH3, NH2 and dimethylamine. Okay, methylamine, dimethylamine and in the aqueous solution. So you have to give the correct order of increasing basic nature for the bases. That is your ammonia. Okay, then you have a methylamine. Okay, and you have a dimethylamine. Okay, and you have a dimethylamine. So give the correct increasing basic nature. How you are going to give the order in increasing basic nature?
Very greater than secondary, greater.
Okay. So here, okay, you have a methyl group. Okay. So methyl, what type is methyl? Is it an electron withdrawing group or electron donating group?
Withdrawing.
Yes, it is a electron
Wit-
withdrawing group. Okay, it is a electron withdrawing group. So now here, because of electron withdrawing group, so when you see NH3, okay, when you see NH3, okay, and when you see your this what your this so CH3 NH2, so what it will do, it will withdraw the electron towards itself, right? So it will withdraw the electron towards itself. So what will happen? There will be plus I effect. So there will be plus I effect. So due to the plus I effect of the methyl group, okay, now here in which the plus I effect will be more, where the plus I effect will be more, the plus I effect will be more in the secondary amines, right? This will be here you can see, okay. So here, what will happen? Secondary amines are more basic. Why? Because plus I effect is more because of the presence of two electron withdrawing group. So because of the presence of two electron withdrawing group, okay, the plus I effect is more here. So secondary is more basic. Okay. So what is the order then? So your NH3, okay, is less than your second primary amine, and then is your dimethyl amine. Okay, so option number D. Option number D. So because of the presence of the electron withdrawing group. Okay, so plus I effect is more. Okay, so because of that, the basic nature will be more. So this is first, then second, and then this. So they have asked the increasing order. So this will be less. Okay, then your primary and then your secondary. Fine. The reaction of benzene disonium chloride with aniline. Okay, the reaction with benzene disonium chloride. So what is benzene disonium chloride? So this is a benzene N2 plus N Cl minus. Yes, so this is your benzene BDC. It is called as BDC, benzene disonium chloride. So when benzene disonium chloride reacts with your aniline, you are going to get a it is called as a coupling reaction, right? It is called as a coupling reaction. So what I'm going to get? I'm going to get a azo compound. I'm going to get what? Azo compounds. Okay, and these azo compounds, they give you a dye. Okay, they give you a color dye. So the reaction of benzene diazonium chloride with aniline yields you what? What it will yield you? So what you are going to get? Okay, so your N double bond N, okay, and your aniline. So I'm going to get a para amino, para amino azobenzene, para amino azobenzene. So when your benzene disonium chloride reacts with aniline, it will give you a yellow dye, and this yellow dye, it is of para amino azobenzene, para amino azobenzene. So option number B. Okay, option number B is the answer. So remember that. Okay, two azo compounds are there, two coupling reactions are there. Both the coupling reactions are very important. Okay, both the coupling reactions are very important. Okay, so option number B is the answer. Okay, next one. Which of the following is more basic than aniline? Which of the following is more basic than aniline? Let me write the structures, okay, then only you will come to know. Diphenylamine, diphenylamine. Now amine, okay, so your what? Diphenyl means NH3, right? So two hydrogens will be replaced by your phenyl groups, okay. So this is your diphenylamine. So this is diphenylamine. Then triphenyl, so NH3, okay. So all the hydrogens are replaced by what? They are replaced by your this, okay. So all the nitrogens are replaced by your phenyl groups. So this is your triphenylamine, okay. Then paranitroaniline. Paranitroaniline is what? Para-nitroaniline, right? Para-nitroaniline. So this is your para-nitroaniline. Okay, and here next is benzyl amine. Benzyl amine means you have a benzyl group CH2 and amine NH2. So again benzyl amine. Okay, can you tell me now which of the following is more basic than aniline? And this is your aniline. Okay, this is your aniline. Can anybody tell me? A diphenylamine, triphenylamine, para-nitroaniline, and D benzylamine. So which is more basic than aniline? What do you think? Which is more basic here?
Benzylamine.
Yes,
Benzylamine.
benzyl amine. Okay. Now, why do you say benzylamine is more basic? Can you give the reason? Because now when you see these structures, okay, now you can see aniline, nitrogen is free here. Nitrogen is free, right? It can
Yes, ma'am.
easily, yes, it can easily donate the pair of electrons. Now in this structure, okay, in your diphenylamine, you can see that the electrons are not free. They are involved in conjugation. They are involved in conjugation. So these electrons, they can delocalize in these two rings. So it will undergo delocalization with these two rings. Now again, this here again this nitrogen here, these electrons, they will delocalize, get delocalized. They are not freely available. Okay, they are delocalized in the three rings. Okay, so here also it is not basic. So and here what will happen here? So because of the nitro group, as nitro group is a electron withdrawing electron donating group, right? So what will happen? Electrons are pulled. Okay, so the electrons so it will electron withdrawing group, right? So it will pull the electron towards itself. So electrons are pulled by this nitro group. Okay, because of the minus I effect. Okay, because of the minus I effect and the minus R effect. So electron density will be less. So again, here also these electrons, okay, your lone pair of electrons are involved in conjugation. Here they are what? There is no conjugation. Okay. So these electrons, they are easily available for donation. So these are easily available. So option number D, benzyl amine. Okay, benzyl amine is a more basic than your aniline. So yes, option number D is the correct answer. So what is the reason? What is the reason why it is more basic than aniline? Because it is freely available. Okay, the electrons, they are freely available for donating. Okay, they are not involved in any conjugation. They are not involved in any conjugation. Okay. Next question. Which of the following will be the most stable diazonium salt? Which of the following will be the most stable diazonium salt? Yes, CH3, N2 plus, X minus, C6H5, N2 plus, X minus. Okay, so again one is your C6H5, CH2, N2 plus, ClX minus. Third one is CH3, that is your ethyl, N2 plus and X minus. A, B, C and D. So which is the most stable? It is your B, right? Your this BDC, benzene diazonium chloride. Why? Because it is resonance stabilized. Okay, it is resonance stabilized. So out of this four, so which is the most stable diazonium salt is your benzene diazonium chloride, because it is resonance stabilized and it is most stable and it is most stable. So option number B. Option number B. Okay. Next question. Which of the following is least soluble in water? Which of the following is least soluble in water at 298 Kelvin? Which of the following is least soluble in water at 298 Kelvin? Methylamine, dimethylamine, This is B option is trimethylamine. Okay, this is trimethylamine. Uh, CH3. Okay, CH3NH2, methylamine, trimethylamine, dimethylamine, and aniline. And aniline. So, which is the least soluble? They have asked. Which is the least soluble? Remember that. So these are what? These are your aliphatic amine, right?
Yes.
Option A, B, and C, they are your aliphatic amine. Aromatic amines, they are insoluble in water. Okay, they are insoluble in water. Why? Because of the larger hydrocarbon part. Okay. So this will, what it will do? It will tend to retard the formation of the hydrogen bond. So option number D. Option number D. So whenever you have a, so for solubility, okay, for the compound to be soluble in water, it should form what? It should form hydrogen bonding. It should form hydrogen bonding. So because there is a large hydrocarbon part, so it will retard the hydrogen bonding formation. So aromatic amines, they are insoluble in water. Okay, remember that aromatic amines, they are insoluble in water. They will retard the formation of hydrogen bonding. Okay, so option number D. Option number D. Okay. Next one, which of the following will have the lowest boiling point? Which of the following will have the lowest boiling point? Which of the following will have the lowest boiling point? Uh, Ethylamine, ether. Okay, you have a, this is your amine. So this is your amine. Just a second. Okay. This is your ethylamine. This is your dimethyl ether. Dimethyl ether. Then this is your formic acid, HC double bond OH, right? This is your formic acid. Then this is your ethyl alcohol. So you have one amine, one ether, one acid, and one alcohol. So they have asked which of the following will have the lowest boiling point. Yes, which will have the lowest boiling point. So remember that for the this okay uh, uh, solubility and your boiling point. Okay. Whenever what is necessary is the hydrogen bonding. Okay, is the hydrogen bonding. Now you put the C in which hydrogen bonding is not possible. Okay, lowest boiling point means the hydrogen bonding is little this. Okay, difficult. Formation of hydrogen bonding is little difficult. So in which of the case you can feel that hydrogen bonding is little difficult? In your ether, right? In your ether. So your dimethyl ether. Okay, so due to the absence of the hydrogen bonding, it will have the lowest boiling point. Okay, it will have the lowest boiling point. So now water, if it is there, water. So this will, your nitrogen will get what? It will form the hydrogen bonding. Again, your formic acid here also. Your hydrogen and your oxygen of the, this will form. Here also. Okay, oxygen and your hydrogen. Okay, again it will form what? It will form the hydrogen bonding like this. But here there is absence. Okay, there is absence of the this what? Hydrogen bonding. So it has the lowest boiling point. Ethers. Okay, your dimethyl ether. Okay. His Hinsberg reagent is. So which is the Hinsberg reagent? Very important. Which is the Hinsberg reagent? Which is the Hinsberg reagent, students? Benzene, benzene sulfonyl chloride. Okay, benzene sulfonyl, very important. Mark, write it out. Which is Hinsberg reagent. Okay, benzene, benzene sulfonyl chloride. Okay. Can you tell me which is the structure? A, B, C, and D.
Option A.
A, right? Benzene sulfonyl chloride. C6H5 SO2 Cl. Remember, very, very important. Can be asked in MCQs, can be asked in fill in the blanks. Okay. Okay. Or it can be asked like this in uh, different form. So, or it can be asked in the question also. What is Hinsberg reagent? How you can differentiate the Hinsberg reagent? Okay. Fine. Next one. The method by which aniline cannot be prepared is. The method by which aniline cannot be prepared is A. Nitration of benzene followed by reduction with tin and concentrated HCl. Degradation of benzamide with bromine in alkaline solution. C. Reduction of nitrobenzene with hydrogen palladium in ethanol. D. Potassium salt of phthalimide treated with chlorobenzene followed by hydrolysis with aqueous NaOH solution. So by which method aniline cannot be prepared? By which method aniline cannot be prepared? Nitration of benzene. Okay, nitration of benzene. So nitration of benzene means I'm going to introduce a nitro group. Okay, this is nitration followed by tin and HCl. Okay, what I'm going to get? I'm going to get the NH2. So yes, by this I can get, fine. This I'm going to get. Then benzamide, okay, from benzamide. So what is benzamide? So this is a Hoffman bromide degradation reaction. So this is my benzamide. So from benzamide also, if I do bromine in aqueous KOH, what I'm going to get? Again, I'm going to get a aniline. Right. So this is a Hoffman bromide degradation. So from this also I can prepare. Now, next is reduction of nitrobenzene. Reduction of your nitrobenzene. So if I have a nitrobenzene and if I do reduction, reduction is what? Removal of this, okay, in the presence of palladium and hydrogen, okay, and ethanol. So what will happen? What I'm going to do? I'm going to, reduction is what? Removal of oxygen, addition of hydrogen. So again, I'm going to get a this aniline. So by these three methods, I can prepare. Last method, potassium salt of phthalimate. Okay, potassium salt of phthalimate, C double bond O, C double bond O, N and K plus. So this is potassium salt of phthalimate. If I treat it with chlorobenzene, okay, chlorobenzene, and followed by hydrolysis with NaOH. What I'm going to get here? Do you know in Gabriel Thalamide synthesis, can I prepare primary aromatic amines? Can I prepare prime? No, right? So from Gabriel Thalamide synthesis, only I can prepare is primary aliphatic amines. Okay, I can prepare only primary aliphatic amines. So only I can take here is alkyl halides. Okay, I can take only alkyl halides, not aryl halides. I can take only alkyl halides. So if I take alkyl halide, I can prepare primary aromatic amines. I cannot prepare aromatic amine. Aniline is what? Aniline is a aromatic amine. So third one, option number fourth one, sorry, by using potassium salt of phthalimide treated with chlorobenzene followed by hydrolysis with aqueous NaOH, I cannot prepare aniline. Okay, but by other three method, I can prepare aniline. Right? Is it clear?
Yes, ma'am.
Okay, fine. So these were the questions. Okay, these were some of the questions from the chapter amines. Okay. So any doubts up to here?
No, ma'am.
Okay. So like this, okay. So I have taken most of the questions. Okay. So very small chapter, but very important chapter. Okay. So mainly Huffman bromamide degradation reaction. Okay. Then Gabriel Thalamide synthesis. Then Hinsberg reagent. Then diazotization. Okay. then reduction method, okay, how to do diazotization, then what basic nature of amines, okay, on these only the questions will be asked, okay. Then again, no, only this is the main concept, okay, so these are the main topics. So based on this only the different type of or different frame of questions will be asked, okay. So if you have any doubts, you can ask me now. So like this, okay, your hand azo compounds, okay, coupling reactions, azo compound. So you need to know this, okay, the structures of quinol, what is the structure of resorcinol, right? So first structure, last structure, if you understood, then you can follow the steps, okay, and you can understand what all you can include, okay, for reduction. What is the reagent used for reduction? Tin HCl, right? So if I would, so if I have a nitrobenzene, if I do reduction, what I'm going to get? I'm going to get a NLE, right? Then again diazotization. For diazotization, which is a reagent, sodium nitrate and concentrated HCl. So what is the condition? Temperature condition 0 to 5 degrees Celsius. So when sodium nitrate, when it reacts with your HCl, what I'm going to get? Nitrous acid, HNO2, right? I'm going to get HNO2. So like this. So so this different this you should know. Okay, what is Hoffman bromide degradation reaction? Okay, Hoffman bromide degradation reactions, they are used for conversions of your amide to amine. Okay, and in amide, whatever the amine you are going to get, you are going to get one carbon lesser, right, from the reactant. Then Gabriel thalamide synthesis. So what is the steps involved in the Gabriel thalamide synthesis? So for what you're going to prepare? You're going to prepare only primary aliphatic amines. Aromatic amines cannot be prepared. Okay. So like this. So these all things you have to study, and organic chemistry practice is much important. You have to write and write. Okay. All the reactions you have to write and practice. You cannot see those reactions and answer, okay. You have to write and practice. So as much time as you practice, okay, so that that many times you will be perfect. So you cannot just see and you can revise, so you have to practice. So whenever you are studying any name reactions, okay, whenever you are studying any this preparations, different methods of preparations, so that time you have to practice, okay, any mechanism, okay. So you have to practice. So stepwise you have to practice properly. And in organic chemistry, when you're writing board exam, for board exams also, so you have to, if they have asked you, okay, explain Gabriel thalamide synthesis, okay, so you have to write the reaction. So whenever you are writing the reaction, now I have written here this, okay, this structure. So if I write this structure, okay, if I write this structure, okay, now this is what? This is a thalamide. So I'll write that name also, thalamide. Okay, write it properly, thalamide. Then react it with KOH. Okay, what I'm going to get? I'm going to get a potassium thalamide. Right, I'm going to get a potassium thalamide. Right. Uh, I'm going to get a potassium thalamide. So here I'll write potassium thalamide. Then next step, I'm going to react it with alkyl halide. So RX. Okay. Then alkyl halide. So what I'm going to get? N-alkyl thalamide. Right. I'm going to get a N-alkyl thalamide. So like this, you have to write the steps in alkyl. Now this is general. Okay, general. They can ask you uh, prepare methylamine. Okay, prepare methylamine. So that time what I'm going to use? N-alkyl thalamide. So thalamide. Okay, let me write first this N-alkyl thalamide. Further, I'm going to react it with NaOH. Okay, what I'm going to get? ONa plus C double bond O Na plus R NH2. Right. Now this is my, so this is a primary amine. Okay. Primary. Now if they ask you prepare methylamine. What is structure of methylamide? CH3NH2. First step will be same. Second step also will be same. What I have to use here? I have to use a methyl, any bromide. Take methyl bromide. Okay. Now what I'll introduce? R will be replaced by your methyl group. Again, R will be replaced by your methyl group. What I got? I got a primary amine like that. So now you have to explain. So one line, short explanation. Phthalimide reacted with potassium hydroxide, okay, to give you potassium phthalimide. Potassium phthalimide further we reacted with alkyl bromide, or you can write methyl bromide to give you an alkyl phthalimide. Further hydrolysis with NaOH gives you a primary aliphatic amine or a methyl amine, like this explanation. So whenever you are writing the name reactions or anything, you have to write properly stepwise, okay? And you have to give a sentence, explanation in sentence. And don't forget to write the names, very important, okay? This will what examiner he will be impressed, okay? He will be impressed by seeing like this, okay? So understood? Is it clear? So like this. So organic chemistry, you have to use some basic this. Okay. So then only you can get good marks. Okay. And don't forget any now for your this what SN1 SN2 mechanism. Okay. Carbocation formation like this. Okay. If you don't write this positive, and if you have written everything, your answer will be wrong. 0 marks. Okay, if you have written everything, first step to last step, but there is no carbocation only. Okay, so means like this, plus sign is not there. Wrong. Again, same. This, what is that? One more mechanism of your, mm, what is that? From alcohol to this alkene, dehydration of alcohol mechanism there also. Okay, first is protonation step. For protonation, okay, you have CH3, CH2, OH, right? I did protonation. Protonation, what will happen? Okay, so I'm going to get CH3, CH2, O plus H2, right? So if I don't write this, if I don't write this, plus here, okay, again I have written here CH3, CH2, OH2. Okay, there is loss of water molecule. I got CH3, CH2. Okay, actually it is like this. What will be the steps? Here one positive, here positive, here positive. Then what will happen? CH3, CH2. Okay, there will be minus H, and I'm going to get alkene. Right. So here, if I don't write this positive here, but everything I have written. Okay, again, 0 marks. Got it? So very important. So all these steps are very, very important. Okay, so remember that. So whenever you are writing organic chemistry, don't forget these all things. Okay. Now, okay, so I just want what all topics we have completed. We have completed haloalkanes, haloarenes, right? Then we have completed all the organic, okay, all the, I think, haloalkanes we have completed, alcohol, phenols we have completed, aldehydes, ketones we have completed, amines we have completed. Okay, then DNF block we have completed, no?
Yes, ma'am.
Okay, again,
Solution.
5
Yes, ma'am. Solutions.
solutions we have completed. Okay, 1, 2, 3, 4, 5, 6 we have completed them. Right, chemical kinetics we did not do. Electrochemistry we did not do. Then this one is there. Coordination compound we did not do. Then biomolecules we did not do. So 1, 2, 3, 4, 5, 6. So only 4 are left now. Okay. So next we will complete this first physical part. Okay. First we'll complete physical part. Then we'll go for coordination and biomolecules. Okay. Fine. So next week we will do, means next when we'll get class, we'll do chemical kinetics. Okay, fine. Okay. So I hope you have understood today's session.
Yes, ma'am.
Yes. Okay, fine. So I will end the session here. Okay. So we'll meet in the next week. Yes. Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you, sir.